Okay, lesson 92. Uniform motion problems. There are 3 types of uniform motion. You will do these in Algebra 1 and again in Algebra 2. All right, so hopefully you can get them down in Algebra 1, so they're super easy in Algebra 2. So the first type of uniform motion problem is equal distances. So all of them that we're doing today are going to be equal distances. Eventually we'll have distances that add to a certain distance, or we'll have unequal distances, okay? But all of them today will be equal. So Candace and Pangloss walked to the site of the disaster in 9 hours. The next morning, they jogged back home in 3 hours. How far did they jog if they jogged 4 miles per hour faster than they walked? So first of all, we're walking there, and we are jogging back. Pretend like that's straight, okay? So we went there and back, which are equal. They are equal, okay? So we want to start by just putting distance walking equals distance jogging. Your equations will always start D equals D today, okay? Equal distances. And then put a subscript that makes sense. You can keep track. So they walked there, they jogged back, okay? Then you replace distance with rate times time. Distance is always equal to rate times time, okay? So this is going to be rate walking times time walking equals rate jogging times time jogging. Okay, you will always do distance equals distance, and you will always do rate times time equals rate times time. Okay, now we'll plug in anything we can. Candace and Pangloss walked to the site of the disaster in 9 hours. Where do you think we should plug in 9 hours? Andrew? Yes. It's a time, okay? 9 hours is time. Hours is time. And this is when we walked there. So I'm going to plug the 9 in for time walking. The next morning, they jogged back home in 3 hours. Where should I plug in the 3? Reagan? Yes, this is time jogging. They spent 3 hours jogging. Nice long jog, okay? How far did they jog? This is a side equation, all right? This is a little separate equation off to the side. How far did they jog if they jogged 4 miles per hour faster than they walked? Now, miles per hour is a rate, okay? Anytime it's miles per hour or kilometers per hour, that's a rate. This is an equation we want to write off to the side, okay? How far did they jog if they jogged, meaning rate jogging? They jogged 4 miles per hour faster than they walked. So that means it's equal to rate walking plus 4. They jogged 4 miles per hour faster than they walked. Okay, write that equation off to the side. Then we plug it in. So now my RJ is equal to RW plus 4. And I squeeze it in. All right, and then I have an RW that I just rewrite. So on this side, I'm going to make this 9RW, so I'll put the 9 in front. And on the right-hand side, I need to distribute the 3. So this would be 3RW plus 12. Then I'm going to subtract 3RW from both sides. That gives me 6RW. And then I've got 12 left on this side. Okay, divide both sides by 6. And that means that my rate walking is 2. Now, my rate, I go back up and I look, what units are we talking about? My rate is in miles per hour. Now, always go back and see what they actually asked for. Sometimes they'll say, what are the rates of both? And then I would just go back over here. I would plug in a 2, and that would mean the rate of jogging was 6 miles per hour. Okay? However, they actually asked in this question, how far did they jog? How far is a distance? How far is a distance, okay? Distance is actually either side, here or here. They are equal. You can plug in wherever you want, okay? Now, I just found that RW is 2. So if I plug in a 2 right here, 2 times 9 is 18. The distance is 18 miles because it's miles per hour. The distance is miles, okay? Now, I also could have plugged in on the other side. I know it's hard to read. I could have squeezed a little 2 in right here. What is 2 plus 4? 6. What's 6 times 3? 18. So whichever side you plug in, you should get 18 because the distances are equal, okay? And you're 18 miles for distance. Okay, let's try one more. There are only 2 examples, okay? On Monday, Voltaire drove to town at 60 miles per hour. On Tuesday, he drove to town at 40 miles per hour. If the total traveling time for both trips was 15 hours, how far was it to town? Little picture, okay? I do want a little picture off to the side. Okay, he drove to town on Tuesday, and then he drove to town on Wednesday. This is a problem that we call same trip. Okay, the last one was there and back. Either way, it's equal distances, okay? So he went there on one day, and then he went there on another day, okay? It's the same distance. So I'm going to do this one as distance Monday equals distance Tuesday. All right, then we always replace our distances with rate times time. So I'm going to do rate Monday times time Monday equals rate Tuesday times time Tuesday. Now they're going to give you bits and pieces to plug in, okay? On Monday, Voltaire drove to town at 60 miles per hour. Where does the 60 go? Yes, rate Monday, okay? Miles per hour is always a rate. Then it says on Tuesday, he drove to town at 40 miles per hour. Where does the 40 go? I'll assume you all said that. Rate on Tuesday. Great, okay? If the total time for both trips was 15 hours, this is an equation you want to write off to the side. How would I write total time is 15 hours? Okay, Knox. Did you say T plus T? Don't do D. Time plus time. Yep. So time Monday plus time Tuesday equals 15. Okay, isolate either one of those. Okay, total time is 15. So I'm going to subtract TT. It doesn't matter which one, but this is the one I'm going to do. All right, so that means that TM is equal to 15 minus TT. So I'm going to squeeze this in right here. For TM, I'm going to replace TM with 15 minus TT, and then I'll keep this TT over here. And then I will solve, okay? So 60 times 15 is 900. And then I'm going to do 60 times negative TT is negative 60 TT. And on this side, we get 40 TT when we multiply those. So then I'm going to add this lovely 60 TT to both sides. So I have 900 equals 100 TT. And divide both sides by 100, and so I get 9 equals TT. Now, they told us that our rates were in miles per hour. So what is this time units going to be? Hours. Okay. Since our rate was in miles per hour, our time is in hours, and our distance is in miles. Okay. So it asks us if the total traveling time was 15, how far was it to town? How far was it to town? Do you guys think the left-hand side or the right-hand side is easier to plug into? Yeah, definitely the right, okay. And I know TT is 9, so 40 times 9 gives me the total distance of 360 miles. Okay, let's try to use our whiteboards and see how